Okay, so we're going to start learning how to calculate the one-way ANOVA. And before we do that, I need to introduce you to some new notation. All right, so I have a sample study up here. Let's say that we're interested in looking at the relationship between noise and memory. And we bring people into our lab and we put half of them in the noise group and we put the other half in the no noise group. And we have them listen to their either noise or no noise, and then we give them a simple memory test. And this data represents the number of items that they correctly remember. All right, so before we go any further, let's identify our independent and our dependent variable. So remember, the independent variable we think of as the cause, the dependent as the effect. So hopefully you're thinking like I am, that the independent is noise and the dependent is memory. Now, if you're ever confused when you look at data, when you're looking at a data set, here's a good way of remembering it. The independent is typically going to be your column labels, all right? So noise and no noise, this is your independent. And the data, the numbers underneath those columns, is going to be your dependent. All right, so now for the new notation. In the ANOVA, we refer to our independent variables by consecutive letters of the alphabet starting with A. Now, for the first few weeks that we do the ANOVAs, we're only going to have a single independent variable. In this case, we only have one independent variable, it's noise, and it has two different levels. But we're still going to start getting accustomed to using that A, B, C notation. So our first independent variable is independent variable A. Now, if we added another independent variable, it would be independent variable B. If we added a third, it would be C, and so on. But for the near future, we're only going to be working with a single independent variable, and that's independent variable A. Now, as we move through the calculations, we need a good way of identifying which group a person is in. So the way that we're going to do that is we're going to consider our noise group to be, sorry, I changed the color here. Our noise group is little a1 and our no noise group is little a2. Now, the little a is important. You're going to learn in a minute that a capital letters have special meaning. All right, so we're going to identify this group as group little a1, and this group is group little a2. So moving through the problem, anytime we see an a1, we know we're talking about the noise group. Anytime we see an a2, we know we're talking about the no noise group. All right, so anytime you see a column of data, remember what you're going to do is you're going to summarize that column with sums, ends, and means. And in the past, we referred to sums with this summation symbol. But we're going to change the notation in the one-way ANOVA and in all the ANOVAs actually. So moving forward, a capital letter refers to a sum. So the sum of this column, the sum of the noise column, we're going to refer to as capital A1. Okay, so capital means it's a sum, and 1 means we're referring to this first group. All right, so the sum of this group is 5. The next thing we do is our n, but again, we want to make sure that we're referring to a specific group. So we're going to call this NA1. And there's 5 subjects in this group. And then our mean is still y bar, but again, we want to make sure that we're referring to the right group. So moving forward, we're going to call this y bar A1. All right, so really the only thing we changed here is we used to use this sigma, now we're doing capital A1, and we're just being much more specific when we refer to the n's and the y bars. So NA1 and y bar A1. So we're going to do the same thing over here. This is group A2, so the sum is capital A2, which in this case is 30. N, we're going to call this NA2, which is 5, and the mean y bar A2 is 6. So we're almost done with this introduction, but we're going to add just a few more important pieces of notation because we're going to need this for the one-way ANOVA as we go through the calculations in the next video. So anytime you see, oh my goodness, anytime you see the little a by itself without any numbers next to it, no capitals, just little a by itself, this means the number of groups or the number of treatment levels. So in this problem, we have 2 treatment levels, so A is 2. Anytime you see the letter N by itself, it refers to the number of subjects per group. Now, in the real world, we could have uneven N. So in the real world, if we were doing research, we could have 5 people in this group, 8 people in this group. It really wouldn't matter. We can still do the calculations. In this class, we're always going to have the same number of people in each group. It just makes it easier to do the hand calculations. But just so that you know, in the real world, this can be uneven. All right, so in this class, N is the, well, always, N is the number of subjects per group, and in this class, it's always going to be the same. So in this particular problem, we have 5 people in a group. There's something called capital T. Hopefully, if you were paying attention, you will remember that I said there's something very special about capital letters. When we see a capital letter, that means it's a sum. So capital T is the grand sum, the grand sum. And what that means is it's the sum of all the scores. So we could either add up all 10 of these numbers, or if we trust our sums down here, we could just add up 5 plus 30. So in this case, our grand sum is 35. And then our last calculation here is y bar t. So hopefully some of you will be able to figure out what I mean by this. So y bar is a mean. The fact that we have a t here probably means something about the total. And in fact, y bar t is the grand mean. And what that means is it's the mean of all the scores. So in this case, we're going to add up all 10 of these scores and divide by 10. For those of you that like formulas, the formula for the grand mean is t divided by little a times little n. So it's t divided by little a times little n. So I'm running out of room here, but it's 35 divided by 2 times 5, which equals, I'm going to put it up here, which equals 3.5. Okay, so I know this might seem like a lot, but there's really not a lot of magic to what we did here, and trust me, you are going to get plenty of practice with this, so if this seems a little fuzzy, don't worry. We're going to practice this over and over and over again. You're going to be able to do this no problem. So just a quick review before I stop the video. This is just about new notation. Moving forward, we are going to be referring to our independent variable in the one-way ANOVA as independent variable A. So in order to identify one group versus another, we're going to refer to this group as 1 and this group as 2. So the column labels are little a1 and little a2. If we had a third group, that would be little a3. Down here, we're not doing anything different than we've always done. We're going to get the sum, the n, and the mean. The only thing we're doing differently is we have just a slight tweak in our notation. So instead of using the sigma, we're going to use capital A1 and capital A2. And the reason that we use these capitals is because capital letters in the one-way ANOVA refer to sums. We have our n and our y bar, and the only thing we've done differently here is that we're identifying it with the group that it is attached to. So NA1, y bar A1, and A2, y bar A2. Moving over here, little a by itself refers to the number of groups. In this case, it's 2. Little n by itself refers to the number of subjects per group. In this case, it's 5. Capital T is the grand sum, or the sum of all the scores, which in this case is 35. And y bar T is the grand mean, which is the mean of all the scores. The formula for the grand mean is capital T divided by little a times little n, and when we do the math on that, that equals 3.5.